Let's take a look at problem number 1 in section 1.1. Problem number 1. True or false? A relation is a function if and only if each element in the range corresponds to exactly one element of the domain. So let's try to keep in mind which is the range and which is the domain in terms of inputs and outputs. So say I've got a bunch of inputs. Let's say we've got 2, 5, and let's say -2. These are my inputs, which we would call the domain. Your domain is always your inputs. In functions, you then apply some function rule to yield an output that depends on which input you choose. That's our range. So for a given function, let's define a function such that f of x equals, let's say, x squared. For this particular function, let's go ahead and analyze what happens to our inputs. So if we have an input of 2, we would say f of 2 equals, and then we put in 2 where x is, 2 squared, which is 4. 2 times 2 is 4. So 2, we would say, yields an output of 4 based on the function rule, x squared. What if we wanted to know about f of 5? Well, then we would do 5 squared, which is 25. So we would say f of 5 gives me an output of 25. What if I use -2? And this is kind of interesting. F of -2 equals -2 squared. Well, what's -2 times -2? Also 4. So 2 and -2 both yielded an output of 4. Now this is actually okay. -2 goes out here to 4 also. This is actually okay because the definition of a function is that every input corresponds to exactly one output. This is the definition of a function. Notice that it's possible for two different inputs to both yield the same output. What's critical is that every input individually can only yield a single output. So is it true that 2 only has an output of 4? Well, according to this function rule, 2 squared will always be 4. It can't be anything else, right? So we have an input that only results in one output. -2 is another input, a different input, that also results in exactly one output that just happens to be the same as the previous one. It also yields an output of 4. But it's still the case that this input, -2, yields exactly one output of 4. Now read carefully what this question is asking us. True or false? A relation is a function if and only if each element of the range corresponds to exactly one element of the domain. They've gotten their domain and range backwards. For an output, an element of the range, actually corresponds, in my example here, the output 4 corresponds to two different inputs. It does not correspond to only one input from the domain. So this is actually false. They've gotten the significance backwards. A function is only a function if every input from the domain corresponds to exactly one output from the range. Items from the range may correspond to more than one item from the domain, from the input. To illustrate this on a graph, I actually copied over a graph of a sine function from Desmos. And on a graph, you'll have the domain or the inputs on your x-axis. Your input is x, that's your domain. And your outputs will be on your y-axis. That's your range. And we'll call that f of x. F of x is what your output is for a given input, x. And notice this sine function, no matter where you go on the inputs, there's only one possible output, right? So say I go to -4. I'm going to pick a little bit darker color here. Let's say I go to -4 as an input. My output, and this is kind of approximate, but let's say my output is approximately 1, let's see, here's my units. So this is 0.5, this is 1, this is 1.5, and this is 2. So about halfway between 0.5 and 1. So I would say f of -4 corresponds to an output of approximately 0.75. It does not correspond to any other outputs. We can keep going up, we can keep going down. We won't find the line representing our function anywhere else. So the input of -4 only gives me one output. That's true no matter where you go. We call that the vertical line test. Can you draw a vertical line anywhere on your graph and always have it only intersect your graph in one place? If you can do that, it's a function, because what that's saying is that for any given input, you're only giving one output. You're only intersecting your graph once. But notice what's happening with running it the other direction. Any given output, well, where else do we see an output of 0.5? If we were to draw a horizontal line, we would also see an output of 0.5 right about here. I don't need my straight line tool. Right about here, corresponding to an input of about 0.75. 1, so here's 0.5, here's 1, here's 1.5, and here's 2. So yeah, about 0.75. So we would also say that f of 0.75 is also equal to, I should have said that was 0.75, right? It's also equal to 0.75. I'm not getting my sevens. Where else is that the case? Well, we also get an output of about 0.75 at, it looks like, this would be 2.5 here. So about 2.5 or 2.25. So we would also say that for this point, f of 2.25, get a lighter color running off the graph, is also equal to 0.75. So on this graph alone, there's at least 3 places, looks like maybe over here too, right? There's 3 or 4 places on this graph alone, 3 or 4 different inputs that all give me the same output. That's okay, because every input gives exactly one output. It does not matter that there are multiple places where this output is created. It does not matter that this output corresponds to multiple different inputs, like -4, positive 0.75, positive 0.275, or positive 0.225. So in this particular problem, we would say is false. They've gotten their range and their domain backwards.